Hello students, today we study the mysteries of 6.2, chemical pipelines and valves. In chemical plants, reactors, agitators, and heat exchangers are all familiar, but have you ever wondered how they connect to allow smooth fluid flow and enable chemical production? Actually, the key to connecting these devices is the chemical pipelines and valves, which act as the plant's lifeblood and switches by controlling the transport, distribution, measurement, and regulation of fluids during production. Chemical pipelines consist of three parts: pipes, fittings, and valves. First, pipes. Depending on the material, they are classified as metal, non-metal, or composite pipes. The pipe specifications are expressed as outer diameter by wall thickness. For example, 32 by 2.5 means a 32 mm outer diameter with a 2.5 mm wall thickness, and common lengths are 3 meters, 4 meters, or 6 meters, with 6 meters being the most common. Metal pipes include cast iron pipes and steel pipes. Ordinary cast iron pipes are used for water and gas lines, while seamless steel pipes can convey high pressure, high temperature, or strongly corrosive media. Non-metal pipes, for example, ceramic pipes, can transport corrosive media, but are brittle. Glass pipes are corrosion-resistant and transparent, often used in special cases. Plastic pipes are for conveying corrosive media. Rubber pipes serve temporary pipelines. Composite pipes combine the advantages of metal and non-metal, enhancing strength and corrosion resistance. Second, fittings. Fittings serve to connect pipes, change diameters, alter directions, branch off, and seal pipelines. Elbows change the flow direction, 45 degree, 90 degree, and 180 degree. Elbows perform according to various pipeline layout needs. Reducers are used to connect pipes of different diameters. Concentric reducers cause minimal flow disturbance, while eccentric reducers facilitate venting or draining. Eccentric types are common in horizontal pipelines. T's and crosses are used for branching. Couplings and flanges connect components of equal nominal diameter in a straight line. Pipe caps, plugs, and blind flanges are used to seal pipe ends. Blind plates can completely isolate a pipeline, making them suitable for maintenance and process changeovers. Expansion joints can compensate for displacements in vessels or pipelines caused by thermal expansion and contraction. Flexible joints are used to connect high-frequency vibrating equipment, providing vibration reduction. Third, valves. Valves are mechanical devices that control the flow of media in pipes, offering functions such as shut-off regulation and throttling. Common in chemical production are gate, globe, and ball valves, each with different operating principles. Please first watch the gate valve video and consider these questions. 1. What are its structural features? How is control achieved? 2. Is it directional? 3. Does it function as a shut-off and/or regulator? 4. Is the pressure loss high or low? 5. What are its suitable applications?
A gate valve consists of a valve body, gate disc, stem, bonnet, gasket, stuffing box, sealing assembly, guide nut, hand wheel, and other components. It features two sealing surfaces with a semi-wedge angle of 5 degrees. The wedge-shaped gate disc moves vertically along the axis perpendicular to the fluid flow direction. When the valve is closed, the gate disc tightly fits against the sealing surfaces, effectively cutting off the fluid flow path. Due to its nearly linear flow characteristic curve, gate valves are unsuitable for precise flow regulation. Therefore, they are primarily used in pipelines, in either a fully open or fully closed state. Gate valves are characterized by low fluid resistance, minimal operating torque, bidirectional flow capability, and excellent sealing performance, making them the most widely used valve type in piping systems of chemical plants. The gate disc is integrally connected to the stem via a T-head joint. When the hand wheel at the top of the valve yoke rotates the guide nut, it drives the trapezoidal threaded stem, engaged with the nut to move vertically. This mechanism converts the rotational motion of the hand wheel into the linear vertical movement of the stem and gate disc. When the hand wheel is rotated counterclockwise, the stem gradually ascends from the valve center, opening the valve. When rotated clockwise, the stem progressively descends, closing the valve. Through this mechanism, the gate valve achieves its fundamental functions of flow path opening and shutoff.
Through study, we see that gate valves use a stem to move the disc up and down to control the opening. Gate valves are non-directional with low flow resistance, suitable for high temperature, high pressure main lines, not for flow regulation and not for conveying suspensions. Similarly, with the questions in mind, we watch the globe valve video.
The globe valve is composed of the valve body, disc, gasket, valve stem, bonnet, stuffing box sealing assembly, hand wheel, and so on. The opening and closing member of the globe valve is a plug-shaped disc, with the sealing surface being planar or conical. The disc moves up and down along the central line of the valve seat. When closing, the pressure from the valve stem makes the sealing surface of the disc closely fit with that of the valve seat, blocking the medium flow. The change in the valve seat opening of the globe valve is directly proportional to the disc stroke, making it suitable for flow regulation and cutoff. The globe valve has the advantages of simple structure, convenient maintenance, short working stroke, quick opening or closing, small friction between sealing surfaces, and good sealing performance, so it is widely used in chemical plants. The head of the valve stem and the disc of the globe valve generally adopt a compression-type connection. The hand wheel set on the valve stem is rotated to drive the valve stem, which drives the disc to move vertically up and down in the valve body, realizing the opening and closing of the valve. When the hand wheel rotates counterclockwise, the hand wheel and the valve stem rise synchronously, lifting the disc to open the valve. When the hand wheel rotates clockwise, the hand wheel and the valve stem descend synchronously, and the disc is pressed against the valve seat to close the valve. The globe valve realizes the opening of the flow channel, the cutoff of the flow channel, and the regulation of flow through the above-mentioned action modes.
Through study, we see that globe valves use a stem to move the disc up and down. To control the opening, globe valves are directional with high flow resistance, suitable for shutting off and regulating high temperature, high pressure pipelines, but not for media with particles or high viscosity. Finally, let's watch the ball valve video.
Ball valve. The ball valve is composed of the valve body, ball core, sealing rings, valve stem, valve cover, limit snap ring, stuffing box seal assembly, and handle. The ball core of the ball valve can perform rotational movement within the valve body. When the ball core rotates to make its internal circular passage perpendicular to the pipeline, the spherical arc surface tightly contacts the sealing rings on both sides, thereby cutting off the flow passage. Since the flow characteristic curve of the ball valve approximates the quick opening type and cannot be used for flow regulation, the operational states of the ball valve in pipelines are essentially either fully open or fully closed. The ball valve is characterized by small fluid resistance, convenient operation, quick opening and closing, and bidirectional flow. Therefore, it is widely used in chemical plants. The lower end of the valve stem is embedded in the groove on top of the ball core. The rotation of the valve stem directly drives the ball core to turn, restricted by the limit snap ring. The ball core can only rotate between 0 and 90 degrees, thereby achieving the opening and closing of the ball valve. Since the groove line at the top of the valve handle is aligned with the internal circular passage of the ball core, when the groove line at the top of the valve handle is in line with the pipeline, the valve is fully open. When the groove line at the top of the valve handle is perpendicular to the pipeline, the valve is fully closed. The ball valve realizes the opening and closing of the flow passage through the above operation method.
Through study, we see that ball valves control the opening by rotating the ball 90 degrees. Ball valves are non-directional, have low flow resistance, are easy to operate, and are suitable for low temperature and high viscosity pipelines, but not for conveying suspensions. Other valves in chemical pipelines include butterfly valves for low pressure or low differential, high pressure lines, check valves to ensure one-way flow, pressure reducing valve to lower and stabilize pressure, and drainage valves to remove condensate from steam lines based on our learning. Let's all take a look at what valves are shown in the video. Now, let's summarize the performance characteristics and applications of the three types of valves. Second, pipeline connection methods. Pipeline connections include threaded, flange, socket, welded, and fusion methods. 1. Threaded connection. Pipes with threaded ends are connected using threaded fittings and screw valves. This method is detachable. Please watch the threaded connection video to understand its method and features.
Threaded connections. consists of externally threaded pipes, sealing tape, and internally threaded fittings. The connection method is similar to the principle of bolts and nuts, belonging to the category of internal-external threaded engagement. Threaded connections offer advantages of simple operation, reliable connection, good versatility, and disassembly capability, making them widely applicable in various low-pressure industrial piping applications. During threaded connection assembly, first wrap the sealing tape fully along the thread direction of the externally threaded pipe. Then maintain concentric alignment between the externally threaded pipe and the internally threaded fitting. Finally, rotate the two externally threaded pipes clockwise to screw them into the internally threaded fitting, thereby completing the pipe connection.
This connection is simple, easy to assemble, disassemble, and low cost. It is not suitable for flammable, explosive, or toxic media pipelines, but is used for water gas lines and small diameter water pipes in low pressure systems. 2. Flanger connection. Pipes, fittings, or equipment are fixed on a flange plate with a gasket in between and bolted tightly. It is detachable. Please watch the flange connection video to understand its method and features.
Flange connections consist of flanged pipes, bolts, nuts, and gaskets. By relying on the gasket between the flanges and applying the specified pre-tightening torque to the bolts, the connection achieves pressure-resistant elastic recovery and effectively seals the medium. Flange connections offer advantages such as reliable sealing, disassembly capability, and wide adaptability, making them widely used in chemical processing equipment. During assembly, first install the bottom half of the bolts and nuts. Then insert a gasket matching the flange's nominal diameter, pressure rating, and medium characteristics into the center position between the flange faces. Next, install the remaining bolts and nuts, using a wrench to evenly pre-tighten the bolts in a crisscross pattern. Ensure all bolts have equal thread exposure on both ends, and that the pre-tightening torque complies with industry standards.
This connection is easy to assemble and disassemble, provides reliable sealing and strong bonding. Though it is more expensive, it is used for media under various temperature and pressure conditions and is widely applied across industries. 3. Socket connection. It can be either rigid or flexible. Please watch the socket connection video to understand its method and features.
Bell and spigot joints consist of bell pipes with circular grooves, sealing rubber rings, and spigot pipes. Bell and spigot joints offer advantages such as quick connection, easy installation, and low cost, making them widely used in large drainage pipeline systems operating under low pressure and low temperature conditions. A bell and spigot joint in piping has a spigot, male end on one side, and a socket, female end on the other, with the bell's inner diameter being slightly larger than the spigot's outer diameter. During assembly, first insert the sealing ring into the grooved bell end. Then align the spigot end concentrically with the bell and insert it. The sealing ring inside the bell tightly grips the outer diameter of the spigot pipe, filling the annular gap between bell and spigot to achieve a complete seal.
This connection is easy to install, allowing slight misalignment of pipe centers and tolerating some twisting, but it is hard to disassemble and not pressure resistant. It is commonly used for low-pressure water pipelines. 4. Welding. Metals or thermoplastic materials are connected by heating and related methods. This connection is low-cost, convenient, and leak-proof. It is suitable for pipes of various sizes and is widely used where disassembly is not required. Class Summary. Today, we learned about the types and functions of pipes, fittings, and valves, the structure and operation of common valves, and pipeline connection methods. Consider whether you have seen similar pipelines and valves in daily life, training labs, or during factory visits, and share what type they might be and what functions they serve.